boy! What we're going to be doing in this video, we are going to be going over how to find the area of a parallelogram. And after we go over how to use the formula to find the area of a parallelogram, we're going to go over why that formula works. So it's not just something learned, memorized, and goes out the one ear. You're going to see how and why. The first step is understanding what the parts of a parallelogram there are. So in a parallelogram, to find the area, the formula is the base of the parallelogram times the height. So I'm going to write that out here, but then we're going to talk about what the base and height are. So the area is equal to the base times, and I'm going to use dot notation, the height. What are each of those things? Well, the base of a parallelogram can be any side of the parallelogram. So not that 5 inches. We'll get to that in a second. So the base could be 12 inches or it could be 6 inches. It depends on the information you're given on the problem. And that information that we're depending on is the next part. The height is going to be the distance from one base to the other. And distance is measured as a perpendicular or right angle distance between one side and another. So if we look at this here, we're given the length from this base up here to that base down there is a nice right angle distance, right? Nice perpendicular distance of 5 inches. So since we're given the height here is 5 inches between these two bases, I'm going to use this base to find the area. The 6 inches is there as extra information. That's all that it is. So I don't have the height that connects this side to that side right there, so I will use the base of 12 and the 5 inches. Super important idea, but I hope pretty clear for you. So now we'll do the area equals the base times the height before going over why that works. So area equals base times height. I'm going to put parentheses like I usually do because visually I think I'm going to enter in the base and the height into those empty variable spots. The base is 12 inches. The height is 5 inches. We multiply it out and we get an area of 60. Your units would be square inches. That's all there is to it. Reminder, we did not use the 6 because we don't have the height that connects this side to that one. Now, if you did want the height, or you were wondering, well, what would the height that connects the 6-inch side to that side look like? Well, it would be a length like this. It would have to be perpendicular and go from one side to the other. It could go from here to here as well. It doesn't matter where it goes, it just has to make a right angle. And that length would be something else. But since we're not given that height, we're not using that base. We're using this base and that height right there. The height can be inside the figure, or it can be, as we saw, outside the figure. So if I drew a height inside the figure here for the 5 inches, that could be something like this, where I drop it vertically down like that, and that would be the same height of 5 inches. Just wanted to show you that heights can come in all different places. The base and height are always perpendicular and make right angles to each other. All right, that's all there is to it for the process. I hope you're going to stick around for this next part because I'm going to go over the why. So let's do it right now. So we're going to go over why the area of a parallelogram is base times height. Well, if we take a look at this, let's cut up this parallelogram. So I'm not going to do what's called for those teachers out there watching this video, I'm not going to do a formal proof, but I'm going to show you a concept, something that makes sense here. We basically cut this down so we make a right angle into a triangle right there. And you see that what we're going to do is we're going to take this triangle on a little journey and see that, wait a second, that triangle is the same triangle that would go right there. Holy cow. So we take this triangular piece here, move it over to there, we get a right angle there. So what I'll do is I'll erase what we've cut off, this guy right here. So we've taken that triangle on a bit of a journey, and what we get, oh, look at that shape, it's a rectangle. And what's the area of a rectangle? Well, the area of a rectangle is length times width. And the length times the width in this particular parallelogram, well, remember the parallelogram had a base here, and then this guy right here was the original height. So length would be base, width would be height, and you get the base times the height gives you the area of this rectangle, which has the same amount of area as the parallelogram did before. Because all we did was, and I'll reconstruct it again, we moved this triangle over to here, and we rearranged the area. So we didn't change the total area of this parallelogram. All we did is move one part of the area over here. So we had the same area, we just reshaped it into a rectangle. So we saw that the area of the parallelogram as is turns into a rectangle that has area base times height. So the original parallelogram has area of base times height. So cool, it involves a little bit of cutting and moving of pieces, but it all relates to the area of a rectangle, which is length times width. Awesome stuff.